Alright, so we're going to close lesson 14.1 and open up lesson 14.2. And now we're going to cover colors. So this might seem a little bit trivial, but actually color is really important to reveal patterns in the data. If used effectively, you can identify and see patterns that you might not be able to observe otherwise, and if used poorly, you can kind of obfuscate or hide patterns. So it's good to know how to wield color, and also to understand what makes a good choice of colors. So we're going to kind of execute these first cells here, and so there's a few different functions that we can use. There's the color palette function, which will give the current color palette. We can also call the color palette function and provide the name of a color palette, and it will produce that. So I think the best way is just to see some examples, and so we can then use this other function, set palette, to set the color palette. So first thing we're going to do is set the default Seaborn defaults here with the default color map. So if we use the function seaborn.colorPalette, it will give us the current color palette, which is this default that's shown here. And then what we're going to do is we're going to use this pal plot or palette plot to all this is doing is just displaying the color palette so that we can see. So it's going to show us these 6 colors. These are the 6 default colors, and if you have up to 6 different lines that you're plotting, it will start with blue and then green and then go through these colors. And if you get to a 7th color, it will go back and use the first color again. But we can adjust that. So we'll see these 2 functions: color palette, which produces the palette object from a keyword or just from the default settings, and then there's pal plot, which will display the color palette, and then there's a third one, which is set palette, which will actually change the color palette. Right now we're just going to observe them. So this is the default theme. It's called Deep, and there are 5 other variations. There's one called Muted, another Pastel, Bright, Dark, and Colorblind. So we can make a loop, so we can just say we can loop through these names, and we're going to then store the color palette of that name as current palette. And in fact, it won't actually be set as the current palette, but it will be saved as this variable name, and then we're going to plot that palette. So yeah, you can see there's Deep. This is the default. Muted, Pastel, Bright, Dark, and Colorblind. You can use whichever you prefer. Colorblind's maybe a good option because you never know who's going to be reading your material, and you want to make sure it's accessible to as many people as possible. So I said, notice we haven't changed the default color map yet. So if we plot these 3 lines, again, we're just using matplotlib functions. You can see that we're using these first 3 colors, so blue, green, red, of this default color map. Excuse me, I misspoke. So what we're actually seeing here are the matplotlib defaults. So this is a little tricky. So yeah, actually, oh, okay, sorry. I was correct. So what we're seeing here, let me specify this a little bit better. So what we're seeing here in this first one is what the defaults were set as. As soon as we typed sns.set, we use this default color map. So you can see that we have these deep blue, green, and red. Deep blue, green, red here. But when we went through this loop, we changed current palette every time we went through that loop. So if we then say set palette to current palette, we're changing it now to after that last for loop. Now, of course, I'll update these all in GitHub after class, so you don't have to worry about having the latest version. So does that make sense? So we went through this loop and we changed the value of the palettes, but this was just for the purposes of palplot, which just shows you the output of that color palette, but doesn't actually change anything internally. We have to use this command set palette to set the color palette, and then and now when we do the same thing, you can see the colors have been changed. Now this is using the this last one here, this colorblind color map. It's a little tricky, but there's a lot you can do with this. So so there's what we call circular color systems. So if you have a certain number of colors, categories to distinguish, so these default color maps are all mainly dealing with categorical data, where you have 3, 4, 5, or maybe even 2 or more than 6. You have some number of categories that are sort of equivalent. So you have apples, bananas, and oranges, right? It's not numerical, they're just 3 different types of things. So you can, one of the ways you can do is you can use this HLS color space to make so this is making the color palette, and then we're just displaying it here. So we're doing everything in one command. If we wanted to use this color palette, we would put this color palette inside of a set palette command. So we can have 8 colors here. If we wanted 10, we could put 10, and you can see it adjusts the colors to match what we provide. You can control the lightness and the saturation using these parameters. And if you want to have a more even intensity across colors, you can use this HUSL system, and you can see the colors here are a little more evenly saturated, or even intensity. Another option for color maps that's really useful is this thing called ColorBrewer. So if we click on this link here, colorbrewer2.org. So this was developed for cartography, but this is a great website. There's so much here that really helps you think about your colors. So it's worth it to consider this for a minute. So basically, you can ask yourself, okay, how many kinds of colors do I want to show? 3, 4, 5. Let's say 3 colors. And then, is your data sequential, diverging, or qualitative? So qualitative is like categorical, right? Each color is its own thing. Whereas diverging, well, let's start with sequential. Sequential is going from like a light to a dark, so low to high. And diverging would be You have low in the middle, and then you have positive values on one end and negative values on the other end. So depending on what you want to show, if you want to highlight both very low values and very high values, you want to use a diverging color map. Whereas if you want to only highlight things that are high or things that are low, you use a sequential color map where you're only really highlighting things in a low range. And if it's not a numerical color map at all, if it's just showing different categories, you want to use a qualitative color map. And so you see your options here, and as you add more colors, you'll see, you can see more things. That you have fewer options. If you want to show 12 colors, you're starting to run out of options that you can use. And if you want it to be colorblind safe, there's no possible way to show 12 colors and not have it be colorblind safe. So and have it be colorblind safe. So given the number of categories and with qualitative, with diverging, it's less essential, but it'll still show you the categories even with diverging. So you might have a diverging system, but there are still categories, if that makes sense. So you might have only finite values, like for example, I like this class very much, or it's okay, or no opinion, or I mildly dislike it, or I strongly dislike it, for example. So anyway, there's a lot that goes into choosing colors. Additionally, I would point out that, so let's say we want colorblind safe, and we've got these 5 options. You can download, let's just say we want it print friendly and not photocopy safe. Okay, that doesn't work. So you can download a program called Color Oracle. This is available for Mac, Windows, and Linux. So this is an awesome program because a certain fraction of the population is colorblind, right? And you don't want to give a talk. You never know. Maybe the chair of your thesis committee is colorblind. You never knew. So you don't want to offend this person, or you want to be accessible. So you can use Color Oracle, and you can automatically see the world through someone else's eyes. So you can say, okay, this type of colorblindness, deuteranopia, affects about 5% of males. So you can see what your color map's going to look like. All right, and you can see that indeed, like even when I change that perspective, I can still distinguish my colors. And there's 2 other types here that also show up. So it's pretty cool. So check it out. So we can have access to these color palettes. So for example, if we want a paired color palette, so we have dark and light, or light and dark, of blue, green, red, orange, purple, and brown. We can make that our color map. So that might be what we want. Or there's all these various other defaults, like this one called set 2, and we can define the number of colors that we want to. You can also specify RGB colors. So any kind of colors you want, you can provide that. Also, if any of you guys ever read the comic XKCD, so a few years ago, he did a poll where he polled all these people about what colors they saw, and so for example, just giving people a color and then having them name it. And so like there are some really interesting trends, like whether females tended to be much more descriptive about the colors, whereas males were a lot of things looked like purple to them or pink, and a lot of things. The key takeaway of this, though, is that they got about over 200,000 people to fill out this survey and name all these colors, and what they were left with was a sort of human average of what a color is, right? It's a very subjective thing, so it's kind of interesting to see what we all sort of agree on about, what is light green versus lime green versus tan versus cyan, aqua, etc. So you can use these color names to color your graph. So let's say you want rust, lilac, and navy. So you can use the Seaborn function xkcd RGB rust. So in matplotlib we have x, y, and color is the standard syntax. So we can just replace the color, which normally would be an R or a B in quotes, or a red or blue, with the xkcd RGB function, and we can use all these colors that are at our disposal. Similarly, we can pass a list of colors to xkcd palette, and it will generate this color palette object, which then we can use set palette, or in this case we'll just show the palette using palplot, and you can see. So it gives you a lot of control over your colors. If you're doing sequential color palettes, we saw that a minute ago. You can there's all kinds of various options, blues, greens, etc. So this would be blues. This would be blue-green reverse, so it goes from dark to light instead of light to dark, just by adding the _R. You can do you have these dark color palettes, which are they don't go quite as light as this one does. You can use this cube helix palette, where you're changing both the brightness and the hue. So this allows you to see more detail in your color map. You're conveying both a darkness and a hue difference. So a lot to think about in terms of choosing colors. And just to see how those come out, so we'll see this in a minute. This is a kernel density plot, but showing you how you can color this kernel density plot with a color map. There's some other sequential palettes, light palette, dark palette. So you can take any given color and make a light palette or dark palette with it. And again, you can reverse it just like you could with those default ones. And this is kind of cool. If you use this as CMap option, instead of generating that list of colors, which you then have to use set palette, you can just, it just automatically will make a color map object. And let's just skip ahead here. So there's also diverging color maps. So brown and blue-green, red to blue. Again, there's a lot of options that you can dig into with Seaborn, and that documentation I showed you, that website is useful. And then I'll just skip ahead here. So we saw that to change the palette, you want to use this set palette. So this will now be changed for all of the plots that you do. Here using this this blue-green color map as well. So again, you can do a with statement, which will only temporarily change the color palette. So yeah, there's a lot you can do. Also, this was the color survey, and I think the results are linked. Actually, they're linked from the notebook. So if we go up to here, there's this this list of colors. So this is the list itself, and you can just scroll through here until you see something you like. For example, if you want snot, blood, earth, it's pretty interesting. Okay.